welcome back to Debugged. Today, we're thrilled to be joined by an incredible guest whose work has shaped how millions of people learn, connect, and create.
I'm very excited to be talking with Karim Meghji, Chief Product Officer at Code.org, where he's helping make computer science and artificial intelligence a fundamental part of every student's education.
He's played a key role in companies like Remitly as Chief Technology and Chief Product Officer, leading the company through rapid global growth and even a successful IPO.
Karim brings a deep passion for customer focused innovation, and today we'll be diving into how those values have guided his career and his vision for the future of tech education. Thank you so much for joining us today, Mr. Meghji. It's really great to meet you and get to talk to you. So today I also have Tushar here, a member of Debugged, also interviewing with me today. So do you want to go ahead and introduce yourself really quickly, Tushar?
Yeah, hi. I'm Tushar. I'm a senior at Parkland High School in Allentown, Pennsylvania. I've been part of Debugged for the last 3 years, and I plan on majoring in CS plus engineering in college.
You've had like a really impressive journey from leading product teams and companies and like real networks to now driving innovation at code.org. So could you explain what inspired your transition from corporate technology to now a education focused nonprofit?
Yeah, for sure. Thanks for having me, first of all, Suhaani and Tushar, on the podcast today. I'm excited to chat with you both and share a little bit of my experiences at Code.org and more broadly speaking. Um, my journey from leading teams, product and engineering teams at for-profit companies to Code.org is really actually uh, a history in like going back to 10th grade when I first used a computer. It was in a math class actually, and I can tell you my teacher's name. It was Bob Van Hoy, and I was in 10th grade. We were doing calculus, and I was a lazy mathematician. I did not like the process of, actually calculating derivatives and integrals. And he said, "Hey, anyone that wants to come after school, I've got this Apple IIe computer that we can do some programming with to calculate some of these things that we're learning about in calculus." And so I was first in line. And that was really my first experience with how computers and technology can help you solve real problems. I didn't know at that moment in time that I would pursue a product and technology career, but that was the moment at which I reached back to when I was in college and said, yeah, this thing about using technology, computer science, and software engineering could be something I want to do.
Yeah, that's amazing, and it sounds like that math class was definitely pivotal in your build up. Can you talk a little bit more about how your work and experience in the different industries such as media, travel, fintech, and what core lessons about building technology like have stayed with you throughout your journey?
The thing that has stayed with me in my entire journey was actually my first job out of college, which was I was answering phones in a customer support line for a product. Symantec Corporation was the name of the company. But the thing that has stuck with me is when you spend hours on the day, hours in the day on the phone with actual customers, you hear their real use of the product and you start to understand the problems that they are trying to solve with your products. And that's the thing that has stayed with me into my entire career is technology solutions are only as good as the problems they solve for humans. And so really understanding the problem, I think, is important. If they understand it, solutions flow a lot easier.
The simpler you look at something, the more likely you are to hit the mark because if you overcomplicate things, you start missing like the real nuance and like the actual problem. So that's a really great point. So Code.org has been a leader in expanding access to computer science for students everywhere. So could you explain what makes you think computer science is such an essential subject for young people today?
Yeah. Yeah, I'll start with the most basic thing, which is, computer science, it's not just about learning about how computers work or programming. In many ways, it's learning about problem solving. It's just a structured way to think about, okay, I've got this ambiguous problem. How do I decompose it, create some abstractions, find the patterns, and ultimately solve a problem? So we sometimes talk about that as computational thinking in quotes, but ultimately problem solving is something that we do in everyday life. You can be a farmer, a biologist, a software engineer, a landscaper. All of these domains of career paths ultimately require some form of problem solving. And so that foundational thinking is one of the core reasons why we believe computer science is important for every student across the globe to learn.
Yeah, as you mentioned, all the students across the world should be learning computer science, especially in today's day and age. But unfortunately, there are students in certain schools that don't have access to computer science, uh, just depending on where they live. So, do you suggest any simple steps that they can take to get started on learning on their own if they don't have these resources available to them?
Yeah, absolutely. The first thing I'll say is, our work is to bring computer science into every classroom across the globe, and our mission is not done until it happens. So, I do hope even for those classrooms and schools today that don't have computer science, we're able to get there. There are things students can do with advocating, getting their parents to advocate with school and district leaders to bring computer science in. So that's one very simple thing that they can do to change the situation for themselves and students at that school in the future. We do that work as well. Um, Aside from that, try an hour of AI activity out during Computer Science Education Week in December. Every year, code.org, along with hundreds of partners, create hour-long activities that students can use just to, in many ways, get a little taste of what it means to learn about computer science, to use technology to build a solution. So that's a very simple step, and it's coming up. It's only a couple months away. So I'd start with that. Code.org has a catalog of videos that are short, just 5 to 7 minute videos on various topics: how computers work, how the internet works, how AI works. Watch some videos, start to get educated around how all these technologies that are in your day-to-day life as a student, how do they work?
Yeah, those are some excellent points, especially because myself, when I was in middle and high school, there wasn't a lot of access to computer science in my like local area. So I did a lot of self-learning, and I remember I used code.org's resources and like really understood what was going on. And later on, I ended up even making a programming club and started using some of the curriculum to help like encourage more students to get into programming. So because code.org's curriculum is also free, it's really accessible. But how does your team balance designing products that are both engaging for students who are trying to self-learn, but also easy for teachers to use on a larger scale?
Boy, it's a balancing act for sure, Suhani. That's a difficult kind of space that we live in. Um, we generally start with the concept of, our products and our curriculum have to be engaging, because if they're not engaging, if students' attention isn't held as teachers are taking them through the curriculum, teachers don't love the product. So in many ways, teachers follow, products that are engaging. We created a new product. Year before last called Music Lab that teaches basic coding constructs using block-based coding. But what it does is it allows students to essentially remix and use code to create new songs from their favorite artists' songs. It's pretty cool and pretty engaging for students. And because it was engaging for students, teachers loved it and brought it in. So kind of the core lesson is you've got to make something that students want to work with. If you do, teachers will use it. Now, it doesn't end there. That's not enough, because not every teacher has spent years learning about computer science or now AI to teach it in a way that shows their depth, right? And so, number one, we have to make the ability for teachers to guide students through that curriculum easy. We accompany all of our curriculum with professional learning. So these are essentially self-paced lessons that a teacher goes through to understand what they're going to be teaching about before they teach it to students. So that's an important component. We give them a lot of resources for student handouts, lesson plans, rubrics. So again, it provides more structure so that the teaching can be easier for them. And then a recent innovation that we've been working on ourselves using generative AI is to bring to our teachers an AI teaching assistant that helps with some of the key pain points that they run into when they're teaching or implementing computer science curriculum in the classroom.
Many of our listeners are also currently creating apps for the Congressional App Challenge, probably using resources like code.org to understand how they should be approaching it. So could you give one piece of advice that you would give them for designing an app that really makes a difference?
Yeah, I think actually, Suhaina, your story earlier about how you use code.org and kind of is a great, like, you're a role model. You're my hero because you you engaged yourself in some self-learning. You thought about something that was kind of important to you, and you kind of tackled it with the resources you had available. And I'd say that's the core part of it. If we find something that's personally relevant, there's an intrinsic motivation to go solve the problem, push through the learning struggles that you might have. And the other thing is there's a pride that comes out of the end state. You've built something, you've also increased your confidence. So I think it's critical for your listeners who are going to create these apps, like do it with something that you're passionate about. Find a problem that means something to you. I think you'll produce something that's incredible and in value. It'll have personal, like inward value. Hopefully, it'll have external value, and you'll learn a ton through the process. And that engagement will drive, I think, a higher level of learning.
Has there been a moment for you where you had a moment of intrinsic motivation and an accomplishment that you're most proud of since you joined the organization?
Yeah. Yeah, I mean, Code.org has had a decade, over a decade of work, and I'm really proud of what the organization has accomplished. Prior to my joining, I joined an organization I was proud of to join. Honestly, I feel there's a privilege and it was kind of an honor to be a part of this organization. Um, I think the change that we are in the middle of right now, where, as a society, we're embracing this new concept of intelligence in a technical form, um, how to use it effectively, how to use it responsibly, learning how it works, um, using it in solutions. I think the today AI can obviously write code for us, and we have to evaluate it. But at the same time, a lot of things that people are going to build or have built and created over the last decade, there are parts of those solutions that now might be solvable with an AI model and the right prompting, right? Or at least subparts of a broader application solution where you can use AI to do some things that were harder to do before. They weren't as achievable um, for a creator or builder. So I think Code.org's shift in many ways to AI plus CS as the thing we need to teach students is what I'm most proud about. And it's really manifested in a new set of curriculum that we just released earlier this year called AI Foundations that brings the best of computer science and AI together. It's a course that we built for every student. Like, our belief is that every student in high school across the globe or at the high school level across the globe should take that course as a way to set themselves up for the world that they will be living in. I'm proud of the team for bringing that curriculum to market. I'm proud of the organization for recognizing the importance of AI in the world of CS and starting to center our work around that. And I'm proud of the way we're starting to use AI ourselves as tools to support students and teachers, a little bit back to some of our earlier conversations.
No, I think it's a really important thing to do right now is to embrace AI rather than like resisting the change. It's almost like the internet coming around and saying, I don't want to use the internet, but the internet is going to be such an intrinsic part of our life that we just have to learn how to use it as a tool. So it's incredible that code.org is quickly making that shift and really helping students embrace it as well. Thank you so much for joining us today. It was a really insightful conversation and it was great to meet you. Thank you again, Tushar, for also co-hosting. Yeah.
Thank you both. Great to meet you, Tushar and Suhaani. Really enjoyed the chat.
Wow, what a great conversation. It's amazing to hear how code.org is not just teaching computer science, but also developing AI curriculum to make sure every student has access to these critical skills.
Absolutely. Kareem's vision for education really highlights how technology can empower students everywhere and the impact that thoughtful product leadership can have on learning at a global scale.
Thank you guys for listening. Be sure to check out code.org if you're currently working on your app for the challenge or looking for ways to improve on a past project. There might be something there that could help.
Speaking of inspiration, let's get to our tech news segment.
Last week, the President signed the executive order launching the Genesis mission, a nationwide effort to use artificial intelligence to speed up scientific discovery. The idea is to bring together decades of federal scientific data and the computing power of national laboratories and build a unified platform where AI can help researchers analyze results, run simulations, and automate parts of the scientific process that are traditionally slow and resource intensive. At the center of the mission is the American Science and Security Platform. Instead of being one single tool, it's envisioned as an integrated research environment that connects national lab supercomputers, secure AI cloud system, standardized datasets, and advanced modeling and simulation frameworks. The goal is to create a place where ideas move more seamlessly from hypothesis to modeling to experimental validation without the fragmentation that usually slows the federal research down. The Department of Energy is responsible for delivering the system, and they've made it clear that Genesis is tied to 3 national priorities, the first of which is strengthening America's energy leadership, which includes everything from advanced reactors to grid modernization. The second is accelerating discovery in science, using AI and computing to push breakthroughs in fields that depend on heavy modeling and complex datasets. And the third is supporting national security through more capable scientific tools and infrastructure. These broad themes give the mission its direction, while still leaving room for different research communities to contribute. As with any large research initiative, there are questions being raised. One possible concern is centralization. A platform that unifies data, computing, and research priorities gives the federal government a stronger hand in shaping what problems get attention. That can help coordinate national challenges, but it may also influence which scientific directions get resources, especially for smaller institutions that rely more heavily on open access. It's not necessarily a flaw, but it's something people in scientific and tech communities should watch out for. Over the next several months, we'll start to see the mission take place. The Department of Energy has a series of deadlines built into the executive order. Within the next 60 days, they must identify the initial set of national science and technology challenges. By 90 days, they're required to map the federal computing and data resources that will support the platform, and by 120 days, they need to select the first datasets and tools that will be integrated. The plan is to have an early working version of the platform demonstrated before the end of next year. These milestones matter because they'll show how the system is expected to operate in practice and how open or restricted it may be for the broader research community. Right now, Genesis stands as one of the most ambitious attempts from the United States to embed AI directly into the core scientific research. If it works as intended, it could change the pace of discovery in fields that normally take decades to move forward. But its impact will depend on how well the technical, scientific, and organizational pieces come together as the mission rolls out.